Hey students, here's the spiral review for Spiral 0A. On here we've got functions and quadratics, which is for feedback, and also trigonometry stuff, also for feedback. So looking at this first problem, we've got f of x and g of x given to us, and we're asked to find f of g of 2. When I see this, the thing that I know is I need to find g of 2 first. So let's find that. G of 2 is going to be 2 squared plus 2 times 2. That gives us 8. Once I have that, I've got to plug that into my function f. So f of 8 is going to be 2 times 8 plus 7. 16 plus 7 is 23. That's my final answer. For the second one, we're talking about a transformation. So I've got to identify what's going on with each piece of this thing. I've got an inside piece, and I've got stuff on the outside. Inside is telling us that we are moving right 3 units. So that means that my 0 coordinate is going to become 3. And I don't want to put parentheses there. So let's just kind of erase that. All right, so then let's take a look at my y stuff. I've got y times 2, and I've got a plus 1 at the end. We're going to use order of operations. So 5 is going to become 5 times 2 and then plus 1, which is 11. So my new coordinates, which used to be 0, 5, are going to be at 3, 11. All right, so now we got some factoring stuff. We're going to do the factoring based on what we have here. So I've got to multiply my first and last term. So we've got a times c is going to be negative 30, and my middle term is going to be 13. Looking for things that multiply to negative 30 and add up to 13. I'm going to pretend that I don't have any idea what that is, so let's go with negative 1 times positive 30. Okay, it's way too far. Negative 2 times positive 15. Okay, that gets me positive 13. Only took 2 tries for that, so that's pretty cool. Let's set up our grouped forms. We got 6x squared minus 2x plus 15x minus 5. Factoring my first pair, we can take a 2x out, leaving me with a 3x and a minus 1. Factoring the second pair, I can take a 5 out, leaving me with a 3x and a minus 1. I can take that 3x minus 1 and put that out front, leave me with 2x and a plus 5. Since that equals 0, we get 3x minus 1 equals 0, which means x equals 1/3. And we get 2x plus 5 equals 0, which means that x is equal to negative 5/2. In order to get credit for this, you need to make sure that you're showing your factoring, since this is a factoring problem. If you do the various other methods, you will not get credit for this work. All right, for the next one, we're factoring again. Cool. We've got 4x squared minus 9. This is going to be a difference of squares. That's going to turn into 2x minus 3 and 2x plus 3. That's equal to 0. We get 2x minus 3 equals 0, which means that x is 3/2. And we get 2x plus 3 equals 0, which means that x is equal to negative 3/2. Cool. On to the next one. All right, this is calculator active. For our first problem, we have a sign thing that we cannot do by hand. We must use calculators. And in order to do that, I'm going to find the inverse sign of negative 0.2. I have to use radians. Cool. So when I do this, so we got 0.2 negative might be nice if I could use my calculator. Okay, there we go. And we want to do our second sign, and when we do that, we get negative 0.2013, which is super useful. So what does this actually mean? Because we got to get all the values between 0 and 2 pi, and that is not any of those things. So when we're thinking about this, we know that sine values are our y values. And what this actually gave us is a point, or where we have uh, our circle height at negative 0.2. So what we just found was that at an angle of negative 0.2013 radians, we ended up getting a y value of negative 0.2. What we need to do is figure out exactly where these values would be if they were on the positive side of our circle here. So if I went around and went a whole nother circle around, okay, so that would be negative 0.2013 plus 2 pi in order to get there. I can do the same thing and figure out where this thing is over here. So if I want to say, okay, we're going from pi, and then we went another 0.2013 beyond that, we'd end up at that same place, because this distance and the one in the fourth quadrant are the exact same thing. So these values, negative 0.2013 plus pi and positive 0.2013 plus pi, those are going to be our values. If you want to get the actual decimal approximations for those, the first one is going to be somewhere around 6.07, and the second one is going to be somewhere around like them using a calculator instead of doing that by hand, which is crazy. 2.939, which doesn't make sense because that should be bigger than pi. I think I subtracted instead of added there. There we go. 3.3416. All right, so for our next one, now we're back to exact values. That actually makes things a lot easier for us because what we're going to end up doing is getting the sine thing by itself. In this case, we're going to add 1 and divide by 2 to get sine squared x equal to a half. Take the square root of both sides, and we get sine of x is equal to the square root of 1/2, and sine of x is equal to the square root of 1/2, but the negative version. I'm also going to simplify this a little bit. I'm going to rewrite this as the square root of 1 over the square root of 2, which is 1 over root 2. And if I rationalize that denominator, that comes out to be root 2 over 2. On the other side, so we got sine x is equal to the negative root 2 over 2. If we think about the type of angle that's going to give us a square root of 2 over 2, we know that's going to be in the pi over 4 family. Those are the places on our unit circle where we have our coordinates as root 2 over 2, comma, root 2 over 2 in various positive negative versions depending on the quadrant. But those are going to be our solutions to this because we have both the positive and the negative versions of these things. So we've got at pi over 4, which is our reference angle. We've got our second one, which is going to be 3 pi over 4. We've got the third one down here, which is going to be 5 pi over 4. And then we've got our final value in the fourth quadrant, which is going to be 7 pi over 4. I know I need all 4 of these because we're told we need 0 to 2 pi, and we have not yet reached 2 pi to get there. All right, next up, I'm going to do a little bit of algebraic manipulation. This is just recognizing that tangent of x is equal to sine x over cosine of x. And when we do that, we end up getting sine squared x over cosine squared x. That's all divided by sine squared x. So I'm going to write that as 1 over sine squared x as a multiplier, just to make that a little bit easier to see. And I'm going to add 2 to the other side to make sure that we just have our trig stuff on one side. My sines can cancel out. I'm left with 1 over cosine squared of x is equal to 2. Now we got a couple of different options here. The first option would be to convert this to secant. If you'd prefer to leave this in cosine, we can take the reciprocal of both sides, and we end up getting cosine squared of x is equal to a half. Very similar to what we just had on the sine squared of x thing, we're going to end up with cosine of x is equal to the positive root 2 over 2, and cosine of x is equal to the negative root 2 over 2. And interestingly, this gives us all of the same things that we had for the previous thing. Since we don't care if we're looking at the positive or negative values, we need all 4 pieces of this, all 4 angles that give us an x value of root 2 over 2. These are all the pi over 4 angles. So we got pi over 4, that's our reference angle, 3 pi over 4, 5 pi over 4, and 7 pi over 4 are our answers. For number 8, we got some factoring. Both of these have a cosine. So I'm going to take a cosine of x out of both pieces, leaves me with a sine of x and a minus 1. All right, so that equals 0. This gives us 2 equations. Cosine of x is equal to 0, and sine of x minus 1 equals 0. That tells us sine of x equals 1. So if I think about this, cosine are my x-coordinates. I'm looking for where x-coordinates are 0. That happens at the top and bottom of my unit circle. We have coordinates that are 0, 1 and 0, negative 1. Since both of those things are coordinates that have an x value of 0, because we're dealing with cosine, those are the 2 angles that we want. So this is going to be pi over 2. And then the one down below is going to be 3 pi over 2. Those are our 2 angles for cosine of x is equal to 0. For the other option, we've got sine of x is equal to 1. That's where our y value is equal to 1. I'm going to do the same procedure. The only time that happens is at the top of our unit circle at 0, 1. That's going to be an angle of pi over 2, which is an answer we already knew we had. These are the only 2 answers that we have for this problem.